Hello guys, welcome back to the channel. For those who have been around so far and those who've just joined us, we welcome you. Everyone who hasn't subscribed, please do subscribe and like the video, share or comment your thoughts, and we keep it moving in that fashion. So we have another situation here. This situation requires us to determine the equation of a geometric or exponential function. In this case, we are given 2 points on the graph as well as the horizontal asymptote. The horizontal asymptote, it's always the value for q. So in this case, the value of this is negative 12. So we have that as well as the 2 points, and we need to know what the values of a and b are. At this point, we don't. But we don't have to worry because we are given 2 points. Each point comes with its x value and y value. So when we substitute the first point, suppose you substitute this point of negative 9, its x value is 0 and the y value is negative 9. You can see that this forms basically an equation where a and b are unknown. And if we change and then substitute the other point, which is the x value for that point is actually 2 and the y value is 0, you will see that we have another equation. So basically we can substitute these 2 points to like separately. We first substitute to 1 point, secondly we substitute the other point, and we have 2 equations. We solve those 2 equations simultaneously, and that will help us know the value of a and b, the values of a and b. Okay, so let's do that and then we'll be fine. I'm just going to create space. I'm just going to create space and then we do that. Let's look at this from here. What do? We're going to have f of x equals to a b exponent x minus 12. That is the equation that we have. Now when we substitute the point of 0 and negative 9, what are we left with? We have negative 9 equals to a b b exponent x, which is 0 minus 12. So you will realize that anything exponent 0, that is 1, then that means a equals a times 1, that's just a minus 12. We have this, and then we can move the 12 to the left rather. Then we'll have that 12 minus 9, which is 3. That means a equals to 3. So we have that, and then now we substitute the point of 2 and 0. Okay, when we substitute that point, what is happening? We are always substituting in this equation. Okay, because I keep saying substitute without stating where I'm substituting, but I hope you get to see that. So let's continue the substitution. When y is 0, we have, okay, already we know the value of a, so I don't think we need to act as if we don't know it when we know it. So we're also going to substitute that, and then we have b, x is 2 for that, and minus 12. Then we can solve for b. 12 equals to 3 times, okay, 4 equals to b squared, 2 exponent 2 equals to b squared, therefore b equals to 2. Okay, we have the value of a, we have the value of b, we are getting somewhere, or we are done with the problem. Therefore f of x equals to a, which is 3, b, which is 2, exponent x, q, which is negative 12. That is the equation. Hey, we are done. Seems like that situation wasn't that complicated after all. So sorry, if I can just summarize here, the general idea is that you are given an equation, and that equation, it has 3 unknown parameters, and then you are given a sketch. That sketch should help you be able to determine all those parameters. Firstly, try to see if some of those parameters you can maybe get them from the sketch itself directly, just as we did for q. You could get it directly from the sketch, and that was easy. And then for A and B, you couldn't determine them directly from the sketch. However, you could use the information given on the sketch to determine them. So look at these points that you're given. Each point comes with its x value and y value. So try to substitute one point at a time. When you substitute one point, you realize that you're going to have an equation, but that equation is going to have two unknown parameters. However, those are the parameters that you're interested in, so you're still safe, you're getting somewhere. Substitute the other one again and see if it gives you the two unknown parameters which are the same as those of the first equation that you created. Sometimes you're not going to have to go the simultaneous route, just as it is the case here. The whole idea was to go the simultaneous route, but we didn't necessarily go that way, or we didn't necessarily take that route because it was easier to solve for A and then solve for B without having to create two equations explicitly. However, this is basically the simultaneous route, but it didn't go explicitly that way as we are used to it when we are doing algebra. Yeah, but nonetheless, this is how you approach the question, and then just solve for all the unknown parameters and then rewrite the final equation whereby you are putting the values of all those unknown parameters, and then you are done. La bonana in the next video. Sharp.